Hello students, let us learn how to balance simple equations. I've taken the very simple example of reaction of hydrogen with oxygen to form water. In order to balance any chemical equation, we need to make sure that each and every atom on the left hand side, that means on the reactant side, is always equal to each and every atom on the product side. Now to start with, in the first step, we first write the number of atoms of each kind on the left hand side and on the right hand side of the equation. So on the left hand side, LHS stands for left hand side and RHS stands for the right hand side. We write the number of atoms of each kind on the left hand side first. So we only write the symbols of the atoms. So the first atom that we have here is hydrogen. Number of atoms of hydrogen are 2. The second atom present here is oxygen, which is O. We only write the symbol of oxygen, O. And the number of atoms present in it are 2. In case of the right hand side, again we have the same atom, hydrogen. So we write H first. And the number of atoms of hydrogen here are 2. So we write a 2 here. Oxygen is O, symbol O. And the number of atoms of O are 1. So we write a 1 here. Now it is very clear by looking at the number of atoms of hydrogen. On both sides they are already equal, but oxygen is not equal. So what do we do now? Now we move on to the second step, wherein we again write the same equation as it is. And in order to start balancing, it is very clear to us that hydrogen is equal but oxygen is not. That means we have to balance oxygen. But how do we come to know which side to start balancing? Do we need to first start balancing left hand side, or we first start with the right hand side? In the case of such a simple equation like this, the only thing that we need to take care of is we need to start balancing from the side which has the least number of molecules. If you look at this equation, there are 2 molecules, hydrogen and oxygen on the left hand side, and there is only 1 molecule, water, on the right hand side. So we start by balancing from the right hand side. So to do so, we first write the atoms as it is. Number of atoms of hydrogen, as we know, are 2. Oxygen is also 2 on the left hand side. On the right hand side, hydrogen was 2 and oxygen is 1. Now, as I've told you, we'll first start balancing from the right hand side. Now, when we start balancing, the first step which you should always do is, right, in the beginning, put a dash as a prefix to each of the molecules given in the equation, so that you are very clear and you know that you have to add any number in the prefix of any given molecule to avoid any sort of confusion while balancing. Now the next step is we need to start balancing from the right hand side. Which number to start from? Always remember, whenever we have to start balancing, we always take the lowest possible number. And the lowest possible number here in this case is 2. And moreover, we also come to know that on the left hand side, we need 2 oxygen atoms. To make this oxygen 2, we only need to put a 2 in front of H2O. So we put a 2 in front of H2O. So this makes number of oxygen atoms, as there was only 1 oxygen atom earlier. So now it becomes 1 into 2. Number of atoms gets multiplied with this number. So 1 into 2. That makes it 2. So now there are 2 oxygen atoms on both sides. 2 here and 2 here. But hydrogen atoms have also changed at the same time. So now the hydrogen atom becomes, this 2 gets multiplied with this 2 which is at the bottom. So 2 and 2 becomes 4. So now hydrogen atoms have changed. So that means we also need to make some changes on the left hand side. We clearly come to know oxygen is already equal. We need to make changes only in the hydrogen atoms. How do we do so? We can do so by simply adding a number over here which would make the number of atoms of hydrogen as 2. We would add 2 in the prefix of H2. So this 2 and this 2 gets multiplied. The number in the subscript and the number here as a prefix, these two always get multiplied. So 2 into 2, that makes the number 4. So from this, we clearly come to know that both the hydrogen atoms have also become equal. Oxygen was already equal. So therefore, in the final result, you must always mention the properly balanced equation again for more clarity. 2H2O plus O2 giving 2H2O is a balanced equation. You all must mention this line when you end the question. So this is how we can actually balance other similar equations of the form N2 plus O2 giving NO2, N2 plus O2 giving NO, C plus O2 giving CO2, C plus O2 giving CO. All these equations can be balanced in the similar way. Let's take another example of sodium with oxygen giving sodium oxide Na2O. Here sodium and oxygen are the reactants and sodium oxide is the product. Again, we start with the same step. We write the number of atoms of each kind on the left hand side and on the right hand side. That means the reactant side and the product side. Now clearly we come to know there are two atoms on the left hand side, sodium and oxygen atom. So we start by writing Na, sodium, Na, number of atoms of sodium are 1 on the left hand side. We write O for oxygen, and the number of atoms of oxygen are very clearly 2 atoms of oxygen on the left hand side. Now let's move to the right hand side. We again write the same atoms. Na is there and there are 2 atoms of sodium. So we write 2 and Na is equal to 2, and we have O oxygen and number of atoms of oxygen is very clearly 1. So we put a 1 here. So we have 1 sodium atom on the left hand side, 2 sodium atoms on the right hand side, 2 oxygen atoms on the left hand side and 1 oxygen atom on the right hand side. Very clear that the equation is not balanced. What do we do? In order to balance, again we move to the second step. We again write the same equation as it is, and this time now we have to decide which side should we start balancing, as both the atoms are not equal on both the sides. We follow the same sequence. Since there are two different, one atom and another molecule on the left hand side and there's only one molecule on the right hand side, we start by balancing from the left hand side. From the right hand side. So let's write it as it is. Sodium is 1, oxygen is 2 on the left hand side, sodium is 2 on the right hand side, and oxygen is 1 on the right hand side. So we have to make this oxygen 2. So in order to do so, we will put we should put dashes in front so as to in the prefix, so that we know that we have to put a number here in the prefix only. Now we start with the smallest number as we discussed earlier, and here we want it to be number 2. We want the oxygen atoms to be 2, so we are going to put a 2 in the prefix of Na2O, sodium oxide. This makes number of atoms, the prefix is 2, so oxygen atoms changes now. There was only one oxygen atom, so 1 into 2, now it becomes a 2. So number of oxygen atoms become 2. So that means oxygen atoms have become equal on both the sides. Now by putting a 2 in the prefix, so sodium atoms also change. This 2 gets multiplied with this 2 which is in the subscript. So 2 into 2 becomes a 4. So number of sodium atoms also becomes 4 now. So now since we know sodium is not equal on this side, on the left hand side, we need to make changes here. Sodium is only 1 and we have sodium over here. That means in order to make it 4, it's very simple for us to make it 4 by simply adding a 4 in the prefix of sodium, Na. So therefore, number of sodium atom changes now. It was only 1 earlier. Number of atoms multiplied with the prefix. So 1 into 4, that makes it 4. So therefore, sodium atoms have also become equal on both the sides. So a very simple equation to balance. In the final answer, we need to write the equation as it is. Again, 4Na plus O2 gives 2Na2O. This is a balanced equation. So this is how we balance simple equation like these. So similarly, the following equations, Na plus Cl2 giving NaCl, Mg plus O2 giving MgO, Ca plus O2 giving CaO, K plus O2 giving K2O can all be solved in the similar way as we have done this equation. Let's take finally one last example of nitrogen, reaction of nitrogen with hydrogen forming ammonia, NH3. Here nitrogen and hydrogen, they are the two reactants and ammonia is a product. As you all must have understood by now, in order to balance any chemical equation, we have to make each and every atom equal on both the sides. Let's begin with the same method. We need to write the number of atoms on the left hand side and on the right hand side. We have two atoms, we have two atoms. One is nitrogen and we write the symbol of N. Hydrogen, symbol H. Number of nitrogen atoms are 2. Number of hydrogen atoms are also 2. So we write them On the right hand side, we again have the same atoms, nitrogen and hydrogen. There's only one atom of nitrogen here and 3 atoms of hydrogen on the right hand side. Now if you look at this equation again, this equation is just not balanced because both the atoms are not equal. Nitrogen is 2 on this side, nitrogen is 1 on this side, hydrogen is 2 on the left hand side and 3 on the right hand side. So in order to balance this, we follow the second step now. We write the same equation as it is. Number of atoms of each kind on the left hand side and on the right hand side. And now which side to choose and which number to start from. So as we have done earlier, we choose the right hand side, that means the product side, since there is only one molecule. There are 2 molecules on the left hand side, there's only one molecule on the right hand side. We start by balancing from the right hand side. Now which number to choose from and which atom to balance first, since both nitrogen and hydrogen are not equal. Now this nitrogen has to be made 2 and hydrogen is already 3 on this side and it is 2 on this side. That means we need to increase this number in such a way so that hydrogen becomes equal. Now, if we do a comparison of the two numbers, we need to decide on what basis are we going to balance this equation. Now, as it is very clear, amongst the 2 atoms, we have to decide which atom to balance first. We always start with a number which has to be increased to a very small extent. That means the least number to be increased. So if we compare between nitrogen and hydrogen, nitrogen on the right hand side has to be made 2. And number of hydrogen atoms cannot be reduced. So let us start by balancing nitrogen atoms first. For doing so, as we did earlier, we need to add numbers only in the prefix. So to make nitrogen 2 on this side, the only way we can do it by putting a 2, because we have to make it 2. So nitrogen now becomes a 2 on the right hand side. So both the nitrogen atom on both the sides is equal now. Now let us see what is the change in the hydrogen atoms. It was 3 earlier. Now this prefix gets multiplied with the suffix 3 into 2. That becomes 3 into 2 becomes 6. So hydrogen atoms are 6 on the right hand side now. We need to make a similar change on the left hand side as well. Nitrogen has already become equal, so we need not make any changes here. We're not going to put anything in the prefix. In case of hydrogen, we have to make it 6. The only way we can make it 6 is we cannot put a 2 here. If we put a 2 here, it becomes 2 into 2, 4. But that is not going to give us the correct answer. To make it 6, we need to put a 3 here. So this is how we come to the conclusion that we should be putting a 3 as a prefix to hydrogen, H2. So 2 into 3, that gives us 6 as the answer. So by doing it in such a way, we get hydrogen atoms as equal on both the sides. So nitrogen is 2 and 2 on both the sides. Hydrogen is 6 and 6 on both the sides. So therefore, our balanced equation is N2 plus 3H2 gives 2NH3 is a balanced equation. So similarly, children, you all can solve similar equations, very simple equations which can be solved in a similar way. AgBr giving Ag plus Br2, that is bromine. Aluminium plus chlorine gives aluminium chloride. Iron plus sulfur giving iron sulfide. Hydrogen plus chlorine giving hydrogen chloride. And calcium plus nitrogen giving calcium nitride. So this is how you can solve simple equations with this method. Thank you.